So the key to this question is remembering what the phrase empirical formula means. An empirical formula is the simplest ratio of the number and type of atoms in a compound. So what I'm going to do first is just count the atoms, and then we'll look at making the ratio. So to help me to count them, make sure I don't miss any, I'm going to cross them out as I go. So I've got 1, 2, 3, 4, 5, 6. So carbon is 6. Let's go for my nitrogens. I can see 1, 2 nitrogens, so N2. I've got 1 S. I've got 1, 2 O's. And then do my H's. 1, 2, 3, 4, 5, 6, 7, 8. H8. Now, if I check and look at this carefully, what I can see is that there isn't a way to simplify this because there's only one S. I can't factor this down anything. So that is actually the molecular formula and also the empirical formula for this substance. Okay, next one, we've got some information. Whenever you get a data, look at it carefully, make sure you understand it. So we've got some melting point information here. It says which of these is pure and which of these is impure. So the thing to remember here is if it's pure, then it has a melting point that is very specific. It doesn't change. If it's impure, then it melts over a range of temperatures. And as soon as we know that fact, we can see that in this example, B would be pure because it melts at a specific temperature. In this case, it's 166. And then we have got A and C are impure, and that's because they melt over a range of temperatures. And by a range of temperatures, what I mean by that is this one starts melting at 163 and finish melting at 165. So that's a range in temperatures in that question. Okay, next question. We have got some information, and to help me process this, I've drawn myself a little picture just to help transfer the information into a visual format. So what I can see, we're doing chromatography, and we're told that an RF value is this, and it says calculate the distance that the spot has traveled compared to the solvent. Right, so what I've done is I've drawn where the solvent front is, and that's 2.4 centimeters. And then what I'm being asked to find is how far this spot here has traveled from the start line. Now, if you remember, the equation for this is that RF equals, I'm going to shorten it down to the spot distance, so how far the spot has traveled, divided by how far the solvent front has traveled. So in this case, my RF value is 0.22. My spot distance is what I am trying to find, and then I'm dividing that by the solvent front, which is 2.4 centimeters. Now, if you're in maths, what you would do here is we need to get the spot distance without the number 2.4 underneath it. So I'm going to times by 2.4, and then over here, I'm going to times by 2.4. So that one will cancel with that. And therefore, my spot distance is going to be 2.4, so put it into my calculator, 2.4 times by 0.22, and that's giving me an answer of 0.528 centimeters. Okay, next one is a 6 marker, and I think these are really important questions. We want to try to be scoring at least 4 marks on these, ideally aim for 5 and 6s. So the approach we've got here, again, we've got information to help us in the table. And the question says, explain the difference in boiling points of the structure in terms of bonding in sodium chloride and water. So I said, we're going to do sodium chloride first. We're going to talk about what the bonding looks like in sodium chloride. Then I'm going to talk about what the bonding looks like in water. Then I'm going to talk about a separation technique. And then I'm just going to explain how we get a pure dry sample as it's identified here. So it's kind of 4 stages to this response. So the first part is explaining sodium chloride structure and why it's got this high, as you can see here, high melting point. So what I've done, as I've said, that sodium chloride is an ionic compound, and I've drawn myself a little picture showing the ionic lattice. I'm telling this is the ionic lattice, and I've given this a key to show that the positive ions are sodium ions and the negative ions are chloride ions. I've then said that there are strong electrostatic attractions that are holding the ions together, holding the structure together. And therefore, because this is strong, it requires lots of energy to break them, and therefore the melting point is very high. So I feel I've got everything that explains that first bit. Water, part 2. So water is a simple covalent substance, and as you can see, I'm going to zoom in for you. As you can see here, I've drawn myself a little water molecule. I've got 2 of them, and then in between the water molecules, these are the weak forces that exist between the molecules. I've also labelled that there are strong covalent bonds in the molecule, but there are weak forces between the molecules. We need a lot of energy to break. So we don't need a lot of energy to break these weak forces because they're only weak, and therefore the melting point is going to be lower for water. Moving on to part 3. What I've done here is I've put my diagram in just to help me explain it to you. I don't necessarily think you have to include a diagram, but it doesn't harm us to do this. So to separate salt from water, so I get the water back as pure water, I have to use a process of distillation, as we can see here. And what I would do is heat this up. The water would boil first because it's got the lower boiling point, and the water would come up to here. It would then condense and form pure water, and the water would then be collected inside the conical flask over here. The sodium chloride would be left behind in the distillation flask, the round bottom flask over here. And then what I would do to that is I just leave that to dry, completely dry, just in one place, leave it completely dry, and then I would get my pure dry salt. So there are all the bullet points that need to be included in your response. What I've then done for you is said, I reckon there's 14 bullet points there. So if you got between 12 and 14 of them, you can give yourself 6 marks. If you got between 9 and 11, you give yourself 5, and you can see so on and so on and so on. And what we're trying to do in all our work here is try and get ourselves into this category. And to do that, you have to put lots and lots of core knowledge into your response.